Well, hello guys and welcome back to Mr. G Physics. Here's Mr. G and this time we're going to be doing another question for the grade 11. This one is regarding redox reaction and it's quite important for the grade 12. That's why I was thinking what to say because you need it also in the grade 12. The topic could be complicated and it's one of the last topics of the year, which is related to redox reaction. But what? Before we move on, before we start, don't forget to subscribe for the channel and thumb up so you can get all notifications and videos I post on regular basis. Well, as I said, we're going to be doing a question on redox reaction. This one was question 9 done in November 2023 in the Eastern Cape province, and it was a paper 2. I did write paper 1, but note it is paper 2. It is paper 2. Okay, so this question is regarding redox reaction. Please let's have a look to the question. The question says a clean piece of copper is placed in a solution of silver nitrate. And let's highlight this one because we're just going to speak about silver nitrate in just a minute. The balanced net ionic equation is the following, and they gave you the equation there. You can see that copper reacts with silver ions, and then a copper ion is formed and silver is also formed. Question 9.1.1, define reduction in terms of electron transfer. And guys, let's write here few things. In previous videos, if you watch my videos, you can see that redox reaction is divided in two main groups. In red, or the word is divided in two parts, in red and ox. Red stands for reduction. Ox stands for oxidation. In both of them, the main thing is that electrons are going to be transferred. So electrons are going to move. Electrons, I'm going to write move in the meantime. All right, so let's define reduction and oxidation in terms of electron transfer. Reduction, let's write it right here. Reduction is the gain of electrons. Reduction is the gain of electrons. All right, so whatever substance gain electrons, we say that that substance is being reduced. Oxidation is the loss of electrons. Is the loss of electrons. Now, this one, both definitions are in terms of electron transfer, but redox reaction or oxidation and reduction can be defined as well in terms of oxidation number. So in terms of oxidation number, reduction is when the oxidation number decreases. That is reduction. So in terms of electron transfer, you have to say that is the gain of electron. In terms of oxidation number is the decrease of oxidation number. It is quite simple to remember. If you know that reduction, decrease in oxidation number, you can use it to remember. In terms of oxidation is the oxidation number increase. The oxidation number increases. So now we know what is redox reaction. We know that redox reaction is divided into reduction and oxidation, and we know what is each of them in terms of oxidation number as well as electron transfer. Guys, that was question 9.1.1 to say define reduction in terms of electrons transfer. You know it is going to be the gain of electrons. So, you know, let's write it here. Gain of electrons. Remember, when we did acid and bases, in acid and bases, the protons were transferred. This time, electrons are the ones that are going to transfer. So it's quite simple. Right? What type of reaction does copper undergo in the equation? Now, to do this one, let's identify everything. Remember, I said to you, I'm going to solve the whole question because I want you to go through the whole topic like a summary. So 9.1.2, the equation was Cu plus a 2Ag plus, it's a reversible reaction. Let me see, it's a reversible reaction. There's an aqueous solution there. I'm going to write the aqueous solution, and it's a reversible reaction. This sign here, this symbol means that the reaction is reversible. It's going forward and backward. Okay, you will learn about this one in grade 12. If you are in grade 12, you know what I'm speaking about. So this one is what happened, and then Cu is in aqueous solution, if I'm not mistaken. Yes, Cu is in aqueous solution. That one is gas, solid. All right. I want to write all the states, guys, because if a teacher watch this one, which we never know, then I may be in trouble. So this one is aqueous, and I think the Ag here is in what state? Is in a solid state. All right, so here we are, guys. This is what we have. Now, for us to identify oxidation and reduction, and therefore to determine the oxidation half reaction and the reduction half reaction, we need to get the oxidation number. So what I'm going to do for the oxidation number, and I'm going to use a different red color for this one, is to write the oxidation number on top or above each of the different atoms there. Okay, that one is important for us to identify this group of rules to follow to determine the oxidation number. So if you follow the rules, I'm going to leave the link here so you can watch the video as well. If you follow the rules, copper will have an oxidation number of 0. This silver ion will have an oxidation number of positive 1. The copper here will have an oxidation number of positive 2. And this silver will have an oxidation number of 0. So the first step, you always identify or determine the oxidation number. Second, we are going to see what happened to each of the different pieces that form this equation. So copper, from reactants to product, there we go. What can you see? The oxidation number increase. Therefore, this one, look here, oxidation number increase, it is oxidation. So this one is oxidation. If you want to justify, you can say that the oxidation number increase from 0 to positive 2. All right, there we go. We have the justification of why copper is being oxidized. It is oxidation, or we say that copper is being oxidized. Let's see what happened to silver. We do the same thing with silver. We come in here, and then we see what happened to silver from reactants to product. Okay, even though this one is a reversible reaction, guys, the left-hand side is always the reactant, and the right-hand side is always the product. So what is happening here? The oxidation number went from positive 1 to 0, so it decreases. Therefore, this one is reduction. So we say that silver ion is being reduced to silver. All right, and now why is reduction? Because the oxidation number decreases from positive 1 to 0. That is why it is reduction. So now we answer a question already which asks about which one and they go. So from oxidation or reduction, copper. What did copper do according to what we look? Copper is oxidation, or it oxidized. So what happened there is oxidation. Let's mark it here. Explain your answer in terms of oxidation number, because the oxidation number increases. I'm just going to write it here. The oxidation number number increases. Right, so here we are. Write down the formula or name of the spectator ions in this reaction, and this is the reason why I highlight the starting point here. We're starting with a solution that is between silver and nitrate, or silver nitrate. This here is divided into silver, which is right here with the reactants, and nitrate, which is an ion, NO3 minus. This one here, guys, is the spectator ion. You can see that it's no more there in the reaction. It was the solution used, but it's gone. So that is the spectator ions. It means it does not form part of the reaction. So here, formulate or name of the spectator ions, you can say that the spectator ion is a nitrate, that is the name, or you can write NO3 minus. This is the answer for that question. If you say that, you'll get 1 mark. Now, reduction half reaction. Now, before we go to reduction half reaction, let's write both of them. And I'm going to show you what are the steps to write oxidation half reaction and reduction half reaction. And also I'm going to show you the steps to balance. So let's imagine this equation is not balanced, and then let's balance this part here. So now, how do we write the oxidation half reaction? Let's begin with oxidation, but it could be any one. So this one is oxidation half reaction. So now, what we have to look? We're going to look what we have on the left-hand side of the arrow and what we have on the right-hand side of the arrow. On the left side, we have Cu, and let me do it with it's fine with that color. We have Cu. I'm going to skip those states for now. They're not important at the moment. And on the right-hand side, I have Cu2+. All right, now, as first step, we're going to balance the number of atoms. So we're going to balance the atoms. We have one copper, the number of atoms is balanced. So I'm going to draw a line. Guys, you don't have to do it like me. You can do everything in one step. I just want to do it step by step so you can see how to approach this question. Cu2+. Now we are going to balance. Once you balance the number of atoms, you are going to balance the charge. Now, to balance the charge, we're going to add electrons by adding electrons. You are going to add electrons in the more positive side. Add an electron to the most positive side. So we have to determine what is the charge on each side of that specific arrow. So that is what we're going to do. The charge on this side is 0. The charge on this side is, yes, you are right, guys, +2. So +2 is more positive than 0, of course. So you're going to add electron on that specific side. How many electrons? Well, as many as you need. So in order for you to have both sides with the same charge. So if I add 2 electrons, remember electrons are negative, so +2 minus or plus a -2, that will give me 0. So I have to add 2 electrons on the right-hand side. And guys, this one now is the oxidation half reaction. Cu, 1 arrow, Cu2+, plus 2 electrons. This is the oxidation half reaction. I hope is clear. This is the oxidation half reaction. Let's do reduction, which follow the same. We follow the same steps to do reduction. Which one is reduction? You go to the equation and you always do it in the same order. On the left side, we have Ag. I'm going to skip the balancing. The numbers at the front, guys, I'm going to skip only for balancing. So this one is not part of this oxidation, half reaction, reduction, half reaction. We keep them out. We're going to imagine they were not there because I want you to see how to balance. All right, so we have silver plus, Ag plus, and this one is for the reduction. Half reaction. We follow the same step. We have Ag plus on the left hand side, and on the right hand side I have Ag. I did write it exactly as it is there. The only thing I skipped was the numbers because I don't want to show you that is the balancing. That is after we balance. But what if you've been asked to balance? Then you don't know what to do, and that is what I want to show you now. So on the left I have Ag plus, on the right I have Ag with no plus. All right, so that is what I have. That is what I write in here. What was the first step? We balance the number of electrons. That was number 1. I'm going to rewrite it just for control. Balance the atoms. If you are with me, you are fine. You know what I'm doing here. So we have 1 silver and we have 1 silver. The number of atoms is balanced. Note, it's not always going to be like that. Ag plus, on the other side I have Ag. So the number of atoms is balanced. Number 2, you're going to balance the charge. You're going to balance the charge. How do you balance the charge? Well, I'm going to write it again. By adding electrons to the more positive side. All right, so we have to determine which one is the more positive. The left-hand side, the charge is positive 1. The right-hand side, the charge is 0. So the left-hand side is more positive than the right. We're going to add electrons on the left-hand side. How many? So we can have equal amount of charge. We're going to add 1 electron. So we're going to add 1 electron. That will give me 0 because will be 1 minus 1. So after you add electron, the final half reaction for reduction is going to be Ag plus 1 electron is going to give me Ag. This one is the reduction half reaction. There we go. So up until here, we have now the oxidation half reaction. We have the reduction half reaction. How to balance? Let's say you've been asked to balance. Well, you have to still arrive to this specific point. You need the oxidation half reaction as well as the reduction half reaction. Now, to balance, and I'm going to make that note here. To balance the equation, you are going to make the number of electrons the same. So let's rewrite both half reactions. You have to start with both half reactions. We have in here that one. Let's rewrite it here. Cu is going to Cu2 plus 2 electrons. This one is oxidation. Just for control, I'm writing that one. And here's my cat on the floor. Now here we have Ag plus 1 electron is going to give you Ag, and this one is reduction. So this is the steps that you have to follow to balance the equation, guys. All right, so now what are you going to do? You are going to make the number of electrons the same. You're going to make sure the number of electrons are the same. Let's write equal the number of electrons. I hope if you are watching me, you know what I meant here. You can write it in your own symbols the way you understand. So we have to make the number of electrons the same. In mathematics, you know you have to multiply by a number. We have 2 electrons on top here, and we have 1 at the bottom. So we can add, we can multiply the bottom, the reduction half reaction, by 2, the whole reaction. So I'm going to rewrite everything, guys. I'm doing step by step. You do not have to do everything, if you understand. But now here I'm multiplying by 2 everything. So it's 2 Ag plus 2 electrons, and this one is 2 Ag. There we go. Now what happened? We have number of electrons on the left side, we have number of electrons on the right, which are equal. They are going to cancel each other. This is like a mathematical equation. Okay, so saying that, we can now combine the two. So we have here Cu plus 2 Ag plus, then is coming the arrow, Cu 2 plus 2 Ag. Guys, if you notice, this one is the equation that we're starting with. Remember, this one is not part of the question. I just explaining how to balance if the question is there. The question just asks for the reduction half reaction. So if we go to the reduction half reaction, there we go. It's for silver. This one is the answer for reduction half reaction. Now, some people will say, but Mr. G, you are a little bit too much, because there is a table called ion table, whatever, which is given to us. Yes. But in the grade 11, the purpose is for you to do it without the table. So what if the table is not there? What if they remove the table? Because you're supposed to learn how to do it without the table. That is why I'm explaining. However, if you learn from school with your teacher how to do it using the table, be my guest. You can use it. The table is quite simple. It makes everything easier. But this one is how to do it without a table. Okay? So if we move on, now the question goes to the most difficult part. They say sulfur dioxide gas is bubbled into an acidified solution. Now, the mediums can be now either acidic or basic. I'm going to speak about that one in a minute. Of potassium permanganate as shown in the diagram below. And there is the diagram. All right. It is observed that the solution turned from purple to colorless due to the reduction of potassium permanganate. So this MnO4 minus, which I'm going to rewrite it here. I couldn't write it. It was very difficult to type it in that way in this program. MnO4 minus. That is the ion that you have here. All right. And then it's going to Mn2 plus. So it's going to Mn2 plus. There we go. During the reaction, SO2 is oxidized to sulfate ions, and sulfate, you all know that sulfate is SO4 2 minus. That is sulfate. Determine the oxidation number of sulfur in SO4 in sulfate. All right, so let's do this one, and then remember I said don't leave. It's a good time for you. If you think it's helping, subscribe for the channel now and thumb up. All right, don't go. I still have to speak about when the medium is acidic and when the medium is acidic or basic. I have the cat here helping me to make the video. We're looking for the oxidation number of sulfur in sulfate. All right, so sulfate is SO4 2 minus. There are certain rules for us, or rules that we have to follow to determine the oxidation number. Okay, oxygen will always have an oxidation number of -2, except in a peroxide. This is not a peroxide. The addition of the oxidation number of every atom that form a polyatomic ion will be equal to the charge of the ion, which is the case. In other words, if we add the oxidation number of sulfur plus 4 times the oxidation number of oxygen, this will be equal to -2. That is a combination of that rule of the polyatomic ion. All right? So if you substitute, you have the sulfur plus 4 multiplied by -2. That -2 is the oxidation number of oxygen. This is equal to -2. If you continue calculating, this one is simple math. This one is minus 8 equal to minus 2. So sulfur is equal to 8 minus 2, sulfur is equal to positive 6. Now, guys, you cannot memorize that is going to be positive 6 because it's not the case. Here is positive 6, but later on, when you do or you have sulfur in any other compound, it may not be positive 6. But anyway, that one is the oxidation number of sulfur in sulfate. It's quite simple. Write down the oxidation half reaction. Now, for here, we have to look at certain stuff. All right, and I'm going to speak about the medium. As I said, don't leave. We're going to be speaking about the medium, which is important. Medium. Now, the medium have to do where is that reaction happening. If you read here carefully the question that say that this one is happening in an acidified solution. So that solution is acidified, is acidic, or is like an acid, let's say. So now this medium can be acidic or alkali or basic. All right, if you remember from acid and bases, this one is coming from acid, this one is coming from base. So when you do this type of reaction, they can happen sometime in an acidic medium and another time in a basic medium. Guys, if this is happening in an acidic medium, it means that sometimes you are going to miss some atoms on either side of the reaction. So to balance the oxygen, you're going to add water, H2O. All right, but when you add oxygen, you have hydrogen. So to balance the hydrogen, then you add hydrogen ions. There we go. So to balance the hydrogen, we're going to add hydrogen ion. That is, if the medium is acidic. If the medium is basic, then to balance the oxygen, we're going to add water. Let me just use this color. We add water to balance the oxygen atom. But as you balance oxygen using water, then you are adding hydrogen. So to balance the hydrogen, if it's a basic medium, we are going to add hydroxide ions. To balance the hydrogen. And this is the basis of this point. So we can now go to the next part of the question, guys, which said, write down the oxidation half reaction. So what is being oxidized in this question? They're telling you the SO2, an aeroplane, is going to be oxidized to form sulfate. So let's go to oxidation. And they are telling you, this one is slightly different from what we've done before. They are telling you that oxidation is going to be SO2 is going to SO4, 2 minus. The step one still the same as before. We have to balance, I'm going to write 1, balance the atoms. Now, know the following. We have sulfur and oxygen on both sides. We have 1 sulfur on each side. We have 2 oxygen on the left. We have 4 on the right. If we write the 4 here, then we unbalance the sulfur. And every time you add numbers, you're going to unbalance the other one. So in this case, we cannot balance without adding water. So to fix that oxygen, we have to add water. We're going to add water to the side that have less oxygen in order for us to be able to balance. So we're going to add water to the left-hand side. So we are going to have SO2 plus H2O is going to be SO4, 2 minus, guys. And then now you can see that we have hydrogen on the left-hand side, but we don't have hydrogen on the right-hand side. So we have to add hydrogen ion. This is an acidic medium. The question telling you that the medium is acidic. So we are going to have here now SO4 plus H2O is going to SO4, my mistake, SO2. SO2 plus H2O is giving you SO4. 2 minus plus H plus. We have to use the H plus to balance the hydrogen. So now we can make the number of atoms equal on both sides of the arrow. Sulfur, we have 1. I'm going to use another color so you can see it. Oxygen, I have 2 oxygen and 1 is 3 oxygen. I have 4 on the right hand side. So how can I fix that one? If I add a 2 at the front of water, I have now 2 oxygen and 2 oxygen there is 4 oxygen. So the oxygen is balanced. I have 4 hydrogen on the left hand side. I have only 1, so I'm going to write a 4 on the right hand side. You must double check. 1 sulfur, 1 sulfur. 2 plus 2 is 4 oxygen on the left. 4 oxygen on the right. 2 times 2 is 4 hydrogen and 4 hydrogen. That number of atoms is balanced. But we are not done. We have to balance now the charge. So now I'm going to write here number 2. Balance the charge. Balance the charge. Remember I explained what we did the previous. Here is all the explanation of what to do step by step. We did for oxidation and reduction. Here is slightly different, but not that of a big thing. Now let's determine what is the charge on each side of the arrow. Here we have that is 0. Here is 0. Here is -2. And here is how much? Well, it's 4 times +1. This one is going to be +4. All right, so that's the +4 charge. 4 minus 2, the overall charge on the right-hand side is +2. The overall charge on the left-hand side is 0. I hope this one is clear. So we're going to add electron on the more positive side, which is on this one. And how many electrons can we add, guys? We are going to add 2 electrons. So the balance oxidation half reaction is going to be the following. SO2 plus 2H2O is giving you SO4, 2 minus plus 4, H plus 2 electrons. This one, guys, is the oxidation half reaction for this specific situation. Remember, we're working with an acidic medium. So this one is oxidation half reaction. Let's do the reduction. The question didn't ask, but we need it because the question asked for balancing. And you know, for balancing, you need both because you need to make the number of electrons the same. So let's do the reduction. Now, reduction is potassium permanganate on one side. This one may be a little bit more tricky. So let's do the reduction and let's do it on this new page. Is MnO4 minus, and on the other side I have Mn2 minus. So we have to balance. Remember, this is happening in a acidic medium. We are going to balance. Number 1, balance the atom. Now, here may be slightly different and a little bit more tricky. We don't have oxygen on the right-hand side. We are going to add water on the right-hand side. So that is what I'm going to do. I have MnO4 minus, then arrow, Mn2 minus, plus H2O. Now I have water or oxygen on both sides, but the hydrogen is now messed up. So we have to add hydrogen ions to balance that one. Where are we going to add? On the left-hand side. So we have now here MnO4 minus plus H plus is going to be giving you Mn2 plus H2O. Let me make sure it's Mn plus, the 2 plus, there we go. Okay, so we are up until here. Now we have to make sure the number of atoms are the same. We have 1 sulfur on the left. We have 1 sulfur, we are here. We have 1 Mn on the left, 1 Mn on the right. We have 4 oxygen. We have only 1, so we are going to write 4 at the front here. We have 4 oxygen, 4 oxygen. For hydrogen, we have 4 times 2 is 8 hydrogen on the right-hand side. We have 1, so we're going to write an 8 here. So now, we're almost done. What is left? We have to balance now the charge. So up until here, the atoms are balanced. We have to now balance the charge. Balance the charge. We're going to add the electron to the more positive side. But before, we are going to determine which side is more positive. So the charges here are the following. For here we have -1. The charge here is, guys, +8. All right, I hope you are with me. Here is +2 and here is 0. Overall, we have 7 electrons here. Positive, the charge of that side is 7 or 7 electron, is +7, is 8 minus 1. The charge on this side is +2. So how many electrons are we going to add and where are we going to add the electrons here? Look, the more positive the left. How many electrons can we add to make 7 equal to 2? Well, we have to add 5 electrons. 7 minus 5 is 2. So it's the same. So in other words, we have to add 5 electrons. What is the reduction half reaction here? It's going to be Mn of 4 minus plus 8 hydrogen ion plus 5 electrons is going to be Mn 2 plus 4H2O. This one is the reduction half reaction. I hope you get it and I hope you understand. This is the reduction half reaction. It's getting dark here, guys. So now we are done with that part. Remember, the question was only for the oxidation, will be that one there. So the marks were for this oxidation half reaction. Now we have to do the net equation, the balance, the net equation, and it's quite simple when you are here already. They say balance the net ionic equation using the balance reaction. So we have, or we need both half reaction. We have the reduction. I'm just going to take the oxidation and write it there at the bottom. Let me copy and paste. I don't want to rewrite all this one. Let me copy and paste it here. Paste. Now, guys, to balance, what do you have to do to balance? Remember, not to balance the net ionic equation. The net ionic equation. You have to make the numbers of electrons the same. We have here 5 electrons. In the reduction half reaction, we have 2 electrons in the oxidation half reaction. So how can we solve this question? We have to make or multiply by numbers in such a way that the number of electrons is the same. We can multiply the first one by 2 and the second one by 5. By doing that, we make the number of electrons the same. But be careful, you multiply the whole equation, guys. So let's do it step by step and trying to not make a mistake. Let's use another color so you can see what I'm doing. I'm going to multiply this whole equation times 2. There you can see it. Let me highlight it. I'm multiplying by 2 the whole equation. So saying that if you multiply the whole equation times 2, you will get that is 2mn of 4 minus plus 8 times 2 is 16 H plus 10 electrons, an arrow, 2mn, I was not going to write the 2mn 2 plus 2 times 4 is 8 H2O. That is the first one. The second one, we have to multiply by 5. Remember, all we're doing is making the number of electrons the same. So we have to multiply by different numbers here. Doing that, what do we have? 5, not the highlighted, it's going to be the pen, is 5 SO2 plus 10 H2O is going to be an arrow, 5 SO4, 2 minus, plus 4 times 5 is 20, H plus 2 times 5 is 10 electrons. Now the number of electrons are the same. What we're going to do, those electrons are going to cancel each other. These 10 electrons will cancel with those 10 electrons. But be careful, because we have also now other common factors on each side of the reaction. And let's maybe mark them so you are clear. We have H plus on here, which is 16. We have 20 H plus there. As well as we have, if I may use another color, let me get another color, this one here. We have the water, 10 on the left-hand side, 8 on the right-hand side. So we have to work with this one, and it's met. The video is going long, so I'm going to do it a little bit faster right now. We have 2 MnO4 minus. The water, the hydrogen plus, and the hydrogen plus is going to go to the right-hand side. So no hydrogen plus on the left-hand side. Here is going to be plus 5 SO2 plus the water. We have 10 and 8. 10 minus 8 is 2. So this one is plus 2 H2O. This water is moving to the left-hand side of the arrow to be cancelled with this one. All right, that is what happened. That is the 2 there. Then is coming the arrow, and then on top I have 2 Mn2 plus the water, remember, moved, plus 5 SO4, 2 minus, and the hydrogen, the 16 is moving here, so we have now 4 plus 4 H plus. And guys, this is the balance equation. We must always check. We have now, let me just take it another color, 2Mn, 2Mn. Now oxygen is a little bit tricky. We have 2 times 4 is 8, plus 10 is 18, plus 2 is 20. On this side I have 5 times 4 is 20. All right, the sulfur, I have 5 sulfurs, 5 sulfurs. The hydrogen I have 2 times 2 is 4, and I have 4. Guys, this is the balance equation, or the balance net equation, without using the table. The table is for grade 12. But guys, it's a good time now to support the channel. If you think it helped, thumb up, subscribe for the channel. This is a very good question to practice. I did as much as I could to make clarity on some topics of redox reaction, but the topic could be complicated. So I thank you all for watching, and I'll see you next time. Thumb up, Mr. Jim here.